let us implement a simple mux called as 2:1 mux. So, what does this 2:1 mux tell us? So, it is going to tell us that there are two inputs. Out of these two inputs, only one data should be selected and that should be shared to the output stage. So, let me write the functional diagram of this mux. So, there are two inputs. Okay. So, this is one input 1, the input 2, and this is my information 0 and this is my information 1, that is information 1 and information 2. And this data, these two informations should be transmitted to this output data y. And how it is directed? Yes, we have a select lines. So, based on this select lines, the information on this I0 can be transmitted to y and information from this I1 can be transmitted to the data from I0 is passed to y, or data from I1 is passed to the output y based on this select lines. So, these select lines are going to control the data transfer from the lines. As a result, these select lines are also called as control lines. Okay, fine. Now, here it tells that it is implementation of 2:1 mux. So, for this 2:1 mux, how many select lines are there? For this 2:1 mux, the select lines are 1. Select lines are 1. Okay, fine. Now, let me just implement the diagram with select lines. So, here I am having information 0 and here I am having information I1. This is my data output. This is called as 2:1 mux, and for this 2:1 mux there is a select line called as S0. So, how data is transmitted? Very simple. I am going to write the table here. So, this table tells me how the data is efficiently transmitted to the output. So, we have the information here. Let me call that information as I0 and I1. So, we have two informations I0 and I1, that is two inputs. So, from these two inputs I have to select only one input at one time. So, based on the select lines. So, this is my select lines and this is my output. So, what is my output here? Y. So, what is my select line? S0. So, my select line is called as S0. Okay, I will tell that whenever my select line is 0, transmit the data I0. Whenever my select line is 1, transmit the data I1. Okay. So, this is my output. So, that means that, so whenever your S0 is equal to 0, that means information 0, that is I0 information is transmitted. I0 information is transmitted, and whatever is the I1 information, that is blocked. Do not transmit the information I1, transmit only the information I0. Similarly, when S0 is equal to 1, that tells that block the information I0. So, whatever is the information I0, please block the data, because S0 is equal to 1, and whatever information is there on I1 line, transmit that information without any disturbance. So, this is the truth table for your 2:1 mux. So, it tells that there are two inputs. From these two inputs, at a time only one output is selected based on this select line. So, whenever S0 is 0, that means that transmit the information I0 and block the information I1. Whenever S0 is equal to 1, that means that transmit the data I1 and block the information I0. So, this is the truth table for this 2:1 mux. Now, let us see how to implement this data using logic gates. So, when I know what is mux, when I know how it is going to work, we need to implement that using basic gates. So, first let us learn how to implement using basic gates. Okay, fine. So, to implement using basic gates, first of all we need to write what is the expression for y. So, what is the expression for y? Let us write the expression. So, as I told previously, we have the truth table. So, from this truth table, so we have our truth table. So, let me rewrite the truth table once again for our reference. So, this is my output y, this is my select line S naught. So, whenever S naught is 0, transmit the information I naught. Whenever S naught is 1, transmit the information y I1. Okay, from this, so let us write what is the expression for y. So, y tells that it is S naught bar into I naught plus S naught into I1. So, this is the expression for your y. So, that is output of mux, that is whenever S naught is 0, transmit the information I naught. Whenever your S1 is high, that is high, transmit the information I1. So, I can write this as S naught bar into I naught plus S1 into I1, that is S1 double bar is nothing but S1. So, this is my output y. So, from this what information is required? From this the information required is there is gate required is 1 AND gate and 2 AND gates and 1 OR gate. Okay. Let us write. So, here I have my S naught select line, and here my information I naught is present, and here we have my information I1. So, S naught, I need S naught bar also. So, I am passing it to a NOT gate. So, this is my NOT gate. So, pass it to a NOT gate, I will get S naught bar. So, what is the expression telling? So, whenever you select S naught bar, which information is transmitted? I naught. So, whenever I select this S naught bar, information I naught, I have my I naught information here, information I naught is transmitted to AND gate. Okay. So, the output of this AND gate is S naught bar and I naught. So, now whenever my S naught is selected, what information is transmitted? I1 information is transmitted. So, this is my I naught I1 information, that is this is my S1, S naught, and this is my I1. So, together it is passed to a OR gate. So, this is my Y output. So, what is my Y output? That is S naught bar into I naught plus S naught into I1. So, this shows implementation of multiplexer using basic gates. And which multiplexer we have implemented? We have implemented 2:1 mux. So, based on the select line, this information either I naught or either I1 is transmitted to the output side. Okay. Now, let us implement 4:1 mux, 4:1 mux or 4:1 data selector. So, what does this 4:1 mux provides the information? It is going to tell us that there are 4 input lines. So, what are the 4 input lines? Let me call that information as data D0, data D1, data D2 and data D3. Okay. There are 4 information lines from D0 to D3. So, now from these 4 inputs at a time, one input should be selected and that should be transmitted to this Y output. So, this is my 4:1 mux. So, out of these 4 inputs, I have to select one data from this and pass it to my output. So, how do I select? Who is going to direct this? So, this direction is given by the select lines. So, since there are 4 inputs, okay, so we will be having 2 select lines. So, what are those 2 select lines? That is called as S0 and S1. So, this is the structure of your mux. Now, let us implement the truth table. Let us implement the truth table. From truth table, let us write the logic circuit. So, what is the truth table? So, there are 2 select lines now. So, one is called as S1, the other one is called as S0, and we have our output called as Y. Okay, fine. How many data lines we have? We have 4 data lines, that is D0, D1, D2 and D3. So, how data is selected to the output? Very simple. So, whenever my select lines both are 0, that tells data D0 is selected at the output. Whenever S1 is 0 and S0 is 1, that tells data D1 is selected at the output. Whenever S1 is 1, S0 is 0, that tells data D2 is only selected on the output line. Whenever S1 is 1, S0 is 1, data D3 is selected on the output line. So, this is our truth table for 4:1 mux. Now, once truth table is ready, we need to write the expression for y. What is the expression for y? Yes, we have here. So, that is whenever we have this S1 and S0 bar, S0 bar, S1 bar, data D0 is transmitted. Okay. Next, whenever we have this S1 bar and S0, data D1 is selected, plus whenever S1 and S0 bar is selected, data D2 is on the line, plus whenever S1 is 1, S0 is 1, data D3 is on the line. So, this is the output expression for 4:1 mux. Now, using this expression, we need to implement using basic gates. So, first the functional diagram is important, next truth table is important, next expression. When these three are ready, we can implement the circuit. So, now let us implement using basic gates. So, from the expression we have select lines, two select lines S1. If you see the expression, there is S1 bar also. As a result, I am passing to a NOT gate and we have S1 bar readily on the line, and we have one more select line called as S0, and S0 bar is required. As a result, I am going to implement using NOT gate. So, S1 bar, S0 bar, S1 and S0 are ready. Now, what is the expression tells? Whenever we have S1 bar and S0 bar select lines, so transmit the data D0, and this is given to a AND gate. Okay. So, what is the output of this gate? So, it is S1 bar, S0 bar and D0. Fine. Next, what is the second term in the expression? It tells cancel. Okay. It tells S1 bar, S0 and D1. That is, we have S1 bar, S0 and then data D1. So, that is given to your, this is data D1. So, output of this gate is S1, S0, D1. Next, third term tells that it is S1, S0 bar, D2. Okay. S1, S0 bar, what information? Second information, that is third information called as D2. So, finally, we have here S1 bar, this is. So, this is S1, S0 bar and D2. So, what is the last term in the expression? It is S1, S0, D3. So, whenever S1 is selected and S0 is selected, data D3 is transmitted. So, what is the output of this? S1, S0, D3. Now, all these things are given to a OR gate. Console. So, this is my output y. So, what is my output y? So, output y tells that it is S1, S0, when both are 0, 0, data D0 is selected. When S1 bar is 0 and S0 is 1, data D1 is selected. When S1 is 1 and S0 is 0, data D2 is selected. Whenever S1 is 1 and S0 is 1, data D3 is selected. So, this is the implementation of 4:1 mux. Next is, let us see the applications of mux. So, where do we find the application of mux? So, application of mux has a great application in communication field. So, example, say I am having a transmitter section. From transmitter section I am getting n number of frequencies. Let me assume that there are 4 frequencies coming called as F1, F2, F3 and F4. Now, at the receiver, say I need to select only one frequency out of this. So, how do I select only one frequency? Very simple. So, since there are 4 frequency, I need to implement a 4:1 mux. So, what it is going to accept? So, all these 4 frequencies are going to be accepted. So, out of these 4 inputs, based on the select lines, it is going to accept one frequency at a time. So, it can be F1 or it can be F2 or it can be F3 or it can be F4. So, out of these 4 frequencies, any one frequency can be selected based on the select lines. So, especially in communication field, mux has greater applications.